And good afternoon. I hope everybody had a nice lunch today. Do we have any PhDs over here, or are they all over there? Over there. Okay. Well, I got a PhD when I was 16. I became a post hole digger. So, that's my PhD. But anyway, I'm going to speak to you today a little bit about asphalt rubber spray apply systems. You heard this morning, if you were over here, Annie and Eric and those, Mark, talk a little bit about the asphalt rubber hot mix. I think one of the things you probably need to understand before I begin is that the asphalt rubber spray apply systems are about 15 years older than asphalt rubber hot mix. So these systems have been applied for quite a long time and probably are nearly over 40 years old now. So we have a lot of history and we have a lot of background as to how these systems perform, where we should use them, and really what kind of cost effectiveness we can look at both in the short term and the long term aspects. And that's kind of also what I'm going to speak about today. When we talk about long term performance, a lot of times we'll get up here and we'll show you before and after pictures of projects and 10 years down the line how they're performing, that kind of thing. It's pretty well documented. I'm not going to really do that today. I'm going to probably take the Quentin Tarantino approach. He kind of, when he makes a movie, he kind of tells you what the end's going to be, and then he shows you how you get there. Well, the end with asphalt rubber spray apply systems is they do perform. They perform for a long period of time. It's well documented, and that's really all you need to know. Now, what I want to show you is how do you get there? How do you build these projects? How do you design these projects to make sure that you're going to get the 10, 12, or 15 years of performance that we say you can? So we're going to start right there. Most of you that are here probably know what asphalt rubber binder is by now, right? Does everybody know? Yeah? Okay. I won't explain it then. Annie did a real good job of that this morning. I have a real long-winded example of what I feel asphalt rubber is, and I'm not going to read it because it takes my breath away, but that's kind of what I feel like it is. And there's a lot of variables to that today as we look at designing these binders. And again, Annie went over that this morning, and it's real important, even with an asphalt rubber chip seal or a cape seal application, any spray apply application for that matter, that you design these binders properly and that you use them in the right use. So we'll go through that. And what is long-term performance? I think everybody has a different, maybe different definition of that. And to me, if I can take a road that is in very poor condition and I can give an agency 10 to 15 years of life on that road, that's good long-term performance, especially if you can do it with a chip seal. So that's kind of what we're going to aim at today. So we're going to take all these variables we're going to talk about and we're going to add them all together and we're going to come up with this long-term performance thing. Okay, the binder design variables, I won't dwell on this too much because, again, Annie went through that this morning, and it's pretty much the same thing when we design a chip seal binder as when we look at designing a hot mix binder. We have specific properties that we're looking for, improved properties, viscosity, penetration, resilience, elastic recovery, those kinds of things, and we have a pretty good idea of where these binders need to be. And the binder properties are affected by the asphalt cement. And one of the things that we do with the chip seal binder, and Annie didn't really talk too much about this, but we really want to develop a binder that is specific to a climatic region. Okay, I wouldn't use a 70 minus 10 up in the mountains for my base asphalt. So we need to really take a look at the base asphalt, and because that's where you're going to get your improved cold temperature properties. But if you've got a climate that doesn't really get cold, then you're not too worried about that. So the asphalt's very important, and we want to select the right grade of asphalt to begin our binder design. Percentage of tire rubber is important. Are we going to use high natural rubber, or are we not? Are we going to use extender oil? Are we going to use SBS polymer in conjunction with the rubber? What type of binder do we want to manufacture for that particular climate? Reaction time is very important. Reaction temperature, the type of blender you're utilizing, and then the agitation during the reaction time and also during the application process. So all these factors come into play, and we want to make sure that we account for all of them and make sure that we're taking care of some of the variables before we get in the field and start working on a project. The unique aspects of asphalt rubber binder materials. As I said, we want to design for the climate. So if we have, for instance, Flagstaff, Arizona, that gets to 100 degrees in the summer and minus 30 in the winter, that's a pretty wide range. It's 130 degrees that we got to try to design a binder around so it can perform when it's cold and it can perform when it's hot. That's what we try to do as best we can when we look at these binder designs. We're looking for those improved physical properties, and particularly the resistance to aging. I don't know if anybody's talked about this in the conference. I haven't heard it stated. But when we take a tire and we grind up that tire and we remove the fiber and we remove the steel, there's a lot of additives and compounding agents that are put into tires when they're manufactured. Antioxidants, anti-ozonates, carbon black, various other additives that are very resistant to aging. And when we take that rubber and we blend it with the liquid asphalt cement, we're imparting a lot of those anti-aging properties into the binder itself. And that's part of the reason why these binders last so long, is because they just really don't age and get hard and brittle like a normal asphalt would. The increased viscosity is very important in the spray-apply applications, and I'll talk about that when we get into construction. And of course, the flexible binder design. We want to be able to be flexible enough to get a binder that's going to perform not only for the climatic region, but for the traffic volumes and various other things that we're looking at in any one agency. I rarely find any city or county that are identically the same and what their problems are. All of them a little bit different. Okay, aggregate quality variables. Now, you know, we can design this binder and we can get the best we can get, but we also have to take a look at the aggregate for the chip seal. It's not just shooting oil on the ground and throwing rock on top anymore. We want a good gradation. And generally we use two types of aggregate, a 3/8 or a 1/2 inch size gradation. It's got to be clean. You notice on the bottom, we don't have much passing the 1/4 inch or the number 4. So it's very, very important to have a one size material, and it needs to be well crushed. We specify 90% of the aggregate needs to have 2 mechanically fractured faces. Now, why would you want that? Because when that rock is placed into that oil and it lays down, you want those fractured faces to interlock, and it gives that chip seal a lot of strength. If you have round rocks, they're going to roll, and we don't want that. We want a very durable aggregate. We don't want it to be soft. We want it to be hard. And then we don't want flat or elongated particles either. They need to be cylindrical in nature. So the asphalt rubber chip seal for a SAM, which is a stress absorbing membrane, you've probably heard that terminology over the last day or two, and then a cape seal. And we'll talk about these two specific applications. And I say for corrective maintenance because most of the time we're dealing with roads and streets for city and county agencies and even for DOTs that are in very, very poor condition. What I mean by that is generally we're asked to take a look at roads that if you have a pavement management system and a pavement condition index, they're ranging from about 30 to 50 or 60 on the pavement condition index. So most of the time, these types of roads you would normally reconstruct. And that's what we've been asked by many agencies to do, is figure out a way that a chip seal or cape seal can make these types of pavements last a long time. So application variables. Okay, now we're going to get into construction. We've got the binder, we've got the aggregate taken care of. Now we've got to take these materials and put them on the roadway. Now, how much patching do you want to do on a road? You can do a lot, but you don't need to do a lot with asphalt rubber. If you don't have base failure, if these old alligatored streets, if you don't see any base failure, as long as the cracks between the alligatored sections are fairly narrow, an asphalt rubber chip seal will glue these things back together. You have to do very little maintenance on them. But if you have base failure, you better fix it. Okay? How much crack sealing do you want to do? Okay? Well, we could probably put an asphalt rubber chip seal on this cheaper than it cost to crack seal it. But the point is that, yes, we do need to crack seal a little bit, even with an asphalt rubber chip seal or an asphalt rubber cape seal. Generally what we recommend is if you've got a crack that's 3/8 to a 1/2 inch wide, you better seal it first. Anything narrower than that, the asphalt rubber chip seal or cape seal can handle that. So you can, again, reduce the amount of preparation work that you have to do. Or you could just smear it on like this. That's probably not the best use of crack sealant, in my opinion. You'd be surprised how often I see this, though. Now, what would you do with a street like that? There's not a whole lot to do with it, is there? There's not very many alternatives left when it gets that bad. In this case, the city that we worked with these types of streets, they had some other issues. They had some other variables in the equation where they absolutely could not reconstruct these streets, and there was reasons for that. So these are the kinds of things that we encounter that we're asked to take a look at and see if we can fix them. So, I would call that corrective maintenance, by the way, definitely. So now we've identified the streets. So we've got our binder designed, and we've got our aggregate pretty well in good shape. And by the way, the aggregate is always pre-coated. Most of the time it's hot pre-coated. We'll run the aggregate through a hot plant, and it'll generally have a 0.5 to 0.75% asphalt put on it. And that helps to kill the dust in the rock, and it also helps with the embedment and retention of the aggregate as the materials are being placed. So we always use pre-coated rock. We always recommend using pre-coated rock. It's very important. So now that we have all these things, these variables taken care of as we're looking at the materials we're going to use, and we've looked at the streets, and we've identified the condition of the streets, now we're going to go to the field, and we're going to blend this asphalt rubber binder, and we're going to put it in a spreader truck, and we're going to go and apply it on the street. So on the left here, you see asphalt transport brings in our PG graded asphalt. We put it in a heat tank. We heat it up to about 400 degrees Fahrenheit. It's then blended with the tire rubber and high natural rubber and extender oil if we're using it, and SBS polymer if we're using it. And that blending process takes about 30 minutes to fill up about a 4,000 gallon spreader truck unit. And we let that react for 45 minutes to an hour. And then we test the viscosity in the field. And this is very important. It's our main way that we can test quality assurance in the field. Because the binder that we pull off of the spreader truck after the reaction is complete needs to meet a certain viscosity range. And that viscosity range is directly related to the initial binder design that we did prior to the project beginning. So this is a way that we can assure ourselves that our quality is very consistent. And if we have a problem with viscosity, then we have to fix it before the material is applied onto the roadway. So again, it's a very simple test, but it's a way that we can assure ourselves that we're doing it right. And I don't know of any other industry that really does this in the field. Okay, let's talk about binder application variables. Okay, we're going to go out now. We blended this asphalt rubber binder, and now we're going to go out and we're going to put it on the road. Generally, depending on the condition of the roadway, the lightest application rate we would normally do with asphalt rubber is about 55 hundredths of a gallon per square yard. And I've been on projects like on that really badly alligator street I showed you earlier that we've shot as high as 75 hundredths of a gallon per square yard. Of course, in Texas, Maksud, where is he? Where's Maksud at? Is he in here? In Texas, they shoot a gallon. They do it big in Texas, Maksud. Yes, they do. Anyway, it depends on the condition of the road, and a lot of that's just by experience. And we make recommendations to agencies all the time as to, what we think you ought to put down based on that condition. And sometimes we'll be doing a project and we vary the application rate from street to street just because of the condition of the street. Now, as that binder's going down, depending on the application rate, then you will adjust the application rate of the aggregate also. Okay? The aggregate on a 6/10 or 65/100 of a gallon per square yard application rate generally would be somewhere around about 28 to 30 pounds per square yard. So the idea is that we don't want to put down a lot of extra rock. We want to get the rock as light as we possibly can because we have to sweep the loose rock off. And we don't want a lot of loose rock flying around in driveways and up on sidewalks and all that kind of stuff. So it's important to control those applications in the field as you're working. This just shows you an idea. This, again, a very alligator street. This is probably around 7/10 of a gallon per square yard, and you can see that the asphalt rubber binder has pretty much filled in all those alligator cracks. You know, and there's not a lot of stress here on a road that's alligatored like this. Those stresses and strains are spread out over the roadway. That's why they're all alligator cracked. The problem that we have is when we're trying to solve thermal cracking problems. That's when we see a problem with reflective cracking. Even if we crack seal them, and even if we put the asphalt rubber chip seal down or the asphalt rubber cape seal down over them, there's a lot of stress and strain in those thermal cracks, and eventually we will see a reflection. It may not be as wide as it once was, but those situations are very, very hard to deal with. Okay, we'll talk about the aggregate application rate. I mentioned to you that the rock is pre-coated, and our application rates, again, will range from about 24, 26 pounds per square yard up to around 32 pounds, depending on the application rate of the binder. It is rolled with pneumatic rollers. If the rock's hard enough, durable enough, we'll also use a steel wheel roller, believe it or not. And it just seats that rock in a little bit better, and the steel wheel would be running behind the pneumatic rollers. But we stagger them. We want to get the rolling done in 3 passes and get that rock embedded down into that oil before it cools off too much. So normally the construction trains are pretty tight. Depends on ambient surface temperature though. If we're doing an asphalt rubber chip seal in the middle of the summer in Phoenix or here, it probably wouldn't be as critical as if we were trying to do an asphalt rubber chip seal up in Truckee, California right now, because it's real cold up there now. So we have to take into account the atmospheric conditions, surface temperatures, and ambient temperatures in the construction procedures. It's very important. After the rolling is done, we sweep the loose rock off. And that is generally very fast. We can generally sweep these chip seals in around 15 minutes. So we want to get that loose rock off of there so we don't have the rock being spread around, like I mentioned earlier, or if we're on a highway, we don't want to have broken windshields. So it's very important to get the sweeping done and get it done in a timely manner so we can get that stuff cleaned up and get it removed. And that's kind of what the surface would look like after the sweeping is done. That's the asphalt rubber chip seal surface. You see there's a lot of aggregate there. Holds a lot of aggregate. Then if you want to make it a cape seal, just throw a slurry seal down and there you go. Now we use different types of slurry seal for different conditions also. We might use a type 2 slurry if we're doing residential streets. We might use a micro surface if we're doing a highway. So there's different uses for the slurry seal also that we look at as we do these projects. So the advantages, we talked about the higher binder application rates. And the reason that we can put down a binder at 6/10 or 7/10 of a gallon per square yard is very unique to asphalt rubber because we have a very, very high viscosity. Generally, we're running somewhere between 1,500 and 4,000 centipoise on viscosity. So it has the thickness to allow for the heavier application rates. It's the same concept like this morning that Annie was talking about when you put in these high binder contents in hot mix. The only reason you can put the high binder contents in is because it's very viscous and very thick. We use high quality pre-coated aggregate, and it's very, very important. The aggregate, to me, is just as important as the binder. You can put down the best binder in the world, but if you put down a bad aggregate, it's not going to work. Mentioned the resistance to aging. I think that's another very, very important point, and it's very unique to asphalt rubber because we're putting in 18 to 20% rubber. So these binders are very resistant to aging. They don't get hard and brittle. Very, very high resistance to reflective cracking. And as in that earlier example, when we look at these really badly deteriorated streets and we recommend an asphalt rubber system on these streets, normally, based on the alternative, the asphalt rubber system is cost effective initially. And that's either in lieu of a thick overlay or in lieu of reconstruction. And as we look at the performance of these roads, the life cycle costs are quite low. So again, if I can save you money initially on your alternatives and make them last 10 or 12 years, that's the goal. That's the goal for us, and it's the goal for you too. So you've got everything in place, and so if you did all this right, you get your long-term performance. It's almost automatic. Now, these systems are very flexible. We use a lot of asphalt rubber applications in other types of uses, things that have just come our way and we've had to try to solve problems. But this first one is a very interesting one where we did an asphalt rubber 3-layer cape seal. Now, Jim Bailey and I, he's with the Western Pavement Maintenance Association. We were looking at a lot of these streets one day, and this one was a little bit beyond alligator cracking. So we came up with a new term. We call it cobbling. It's beyond alligator cracking. And these were the kinds of streets that we were asked to try to rehabilitate. And so it brought up a little bit different problem. I mean, we had really wide cracks between the alligators. They were ½ wide in some places. So even a heavier application rate of asphalt rubber binder in the chip seal part of the cape seal probably wouldn't have performed as well as we'd like. So we looked at some other streets, and the best part of the street was where the utility cuts were put in. You ever seen that before? So what we did is we came up, along with the city engineer in this particular city, we came up with a 3-layer cape seal application. And what we did is we went in and we put down a microsurface first to try to fill in all these really wide cracks and to try to stabilize some of that alligator cracking. Looked like that after it was done. Then we came back with the asphalt rubber chip seal, and it looked like that. And then we did the type 2 slurry seal over that, so it was a 3-layer system. The oldest street we have with this system on it is now 4 years old, and you can go back and look at that. It's on a street that services a bunch of fruit packing plants on the California coast, and there's not one crack coming back through. This system was a little more expensive than what we normally do, but the alternative was 3 times more. So we were able to come up with something that appears like it's going to perform very well. BST, Jeff Van Skyke talked about that earlier this morning. I won't get into that too much, but it is a great way to rehabilitate or to actually surface and take care of dirt roads. Scrub seal, we've developed some scrub seal binders that are very interesting, and we do that where we've got alligator cracking, and actually here in California we call it a prep seal, and we're working on these binders to just seal minor alligator cracking before a slurry or an overlay or something like that. It's like a massive crack fill kind of an operation. So that's an interesting development with these binder materials, and basically we spray the material on the road and there's a hydraulic squeegee on the back and it just kind of squeegees the binder right into the cracks. We do bridge deck applications and sealing, expansive soil treatments, embankments, subgrade we apply the binder under subgrade so we can again do protect the expansive soils from moisture intrusion. So this binder is 100% waterproofing also. And we do pond liners. And we've done a lot of work in the mining industry to seal off leach pads where they take ore tailings and they stockpile them on these pads and they sprinkle it with hydrochloric acid solution and wash the fine gold out of the tailings, but they got to protect the groundwater. So we've done a lot of work in the mining industry. But all of this might tell you that it's just a miracle product and it's going to work on everything you do, and that's not really the truth. You got to do the pre-maintenance, like I said. You got to fix the base failures. You got to seal the wide cracks. You got to prepare that pavement to receive the surface treatment. You got to look at your climatic region, your binder design, your aggregate. Construction procedures and details change from job to job, and you have to have good specifications, but you also have to be flexible enough in the field to make changes. Traffic conditions are very important. When we look at a lot of truck traffic, it really is a big part of how we design these chip seals. And then, of course, the construction data. Are you working late in the fall or early in the spring? Do you have temperature considerations to consider when you're looking at construction? But don't let the variables get you down, because if you handle all these prior to the job and get a lot of these questions answered, you will not only get a good project, but it will last you as long as you think it should. And we've seen hundreds and hundreds of examples from many, many agencies that this is, in fact, true. And I've got asphalt rubber chip seals and cape seals that are over 20 years old with no maintenance in 20 years. So with that, I'm going to say that all these variables, if you take care of them, lead to long-term performance and cost effectiveness. And again, it's well documented. We've got 40 years of history. So I thank you, and we'll answer questions if you have any.
A couple of questions, one up here. Wait, just a moment, please. The microphone.
Oh. How much thickness you added through this layer process, 3-layer process?
As far as the overall thickness of the system itself?
Yes.
It's generally about 3/4 of an inch
Thank
total.
You.
Also in the 3-layer process, actually pretty impressive for the state of the roadway. Was this project done in a place where you didn't have a large freeze-thaw effect? And if it was, would this also be applicable in areas where you would potentially have a fairly severe freeze-thaw, like up in Truckee or something in the higher elevations?
Well, this was actually done over on the coast, so the temperature and the climate there is fairly constant, and there's no freeze-thaw cycles there. But I think in pavements that are in that condition, if you don't have a lot of thermal cracking problems, because you have a lot of thermal cracking up in the high elevation normally, if you don't have a lot of thermal cracking problems, this system would work just fine in any climate. You just have to design the binder and the system for that climatic region. Yes.
Have you had any bleeding problems with any of these rubber chip seals, and with high traffic condition and high temperatures?
Yes, there are some issues with them, and there's some things that we try to design around. If you get too heavy of an application rate in an intersection, you might see some flushing. We designed around that on this particular one particular job, and we have a very busy intersection done with this 3-layer cape, and it's not bleeding at all. Also, like cul-de-sac areas and things like that are very, very unique places, and that's where we actually look at upgrading the binder, so to speak. And if we take out a couple of percent rubber and put a couple of percent SBS polymer in, we really increase the physical properties of the binder. And it seems to work in these types of areas, and it maybe not prevent flushing, but really slow it down. So, but yeah, there are some areas where that may happen, and you have to be careful with those. Very good question.
For use as on a bridge deck, was that just the binder only shot down as a membrane, or did that include aggregate as kind of a SAMI?
It actually originally initiated as a SAM application. So we basically did an asphalt rubber chip seal on the bridge deck. About 4 years later, they overlaid it. But it served as basically a waterproofing membrane for the bridge deck to protect it.
So what's the real advantage of placing the slurry seal over the chip seal?
Well, generally when we look at putting the slurry seal over the chip seal, most of the time it's only in residential areas, because if you put down a 1/2-inch aggregate on a chip seal on a residential street, most people don't like that very much. It's very coarse in nature, and Tommy can't ride a skateboard anymore. So really the initial use of it was just to put the slurry down to smooth that out and give it that smooth texture, so the residents were happy. And that's pretty much what we do. We don't do a lot of cape sealing on major highways. The asphalt rubber chip seal is generally just used for that.
Does the slurry have rubber in it?
We haven't done anything with the rubberized slurry in conjunction with the asphalt rubber chip seal, but I don't know why you couldn't.
In the 3-layer system, what was the reason of putting the first layer? You couldn't just put the chip seal and then the slurry seal, or just spray some soft binder, then do the other two layers?
Well, the reason that we chose the three-layer was that the cracking between the alligatored sections of the pavement were very wide, half-inch to three-quarters of an inch wide. And when you put an asphalt rubber chip seal over something like that, even at a very heavy application rate, the binder is going to sag down into those cracks and it's going to elongate. And when that crack starts moving a little bit, the binder may not have the ability to resist that reflection. So what we did with using the microsurface first, we used that to bridge over all those cracks, and then that allowed the cape seal to perform its function, and that was to resist the reflective cracking and not let any of those reflections come through. So it was just a condition of that particular street or streets that we did that we decided to do something like that instead of just a two-layer system.